Hello AAF kids, second semester. We are going to have so much fun. Even though there is no school, I can still get to you and teach you some math. Yay! So second semester is Algebra 2 kind of for real. If you think about it, we really didn't do too much Algebra 2 first semester, except for maybe the last unit. So what you have to look forward to, Unit 6 is rational functions, which is a ratio of polynomials, which is why you study polynomials before this. Unit 7, exponential and log function, that is one of our longest units. Students tend to find that a little bit challenging. Unit 8 is a short one, radical functions. It really belongs in Unit 7, but because Unit 7 is already so long, I kind of tore it off to make it own little mini unit. Then Unit 9 is trig, and we finish up with conic sections, which is sad in a way because conic sections is really cool. It kind of gets a short shrift now that there's standardized testing, HSAs and then parks, and it kind of cuts up this last unit and makes us have to rush through it, and that's a shame. Anyhow, as you can see, there are 5 units for second semester, so one of the quarters will have 3 unit tests, one of the quarters will have 2, just like first semester. What is going to be the predictor of your success in this second semester, which is more challenging, I will admit, than first semester, is your Algebra 1, the real Algebra 1. All the algebra manipulations, how quickly can you do it in your head, and of course that all begins with factoring. Before we get to factoring though, we're going to talk about recommendations for next year. That's going to, especially with these snow days, signing up for next year's courses is going to come really quick. So you are required to take a math class next year, both for the county and for your IB diploma. So given that this was IB Algebra 2, the next course that you take is IB Pre-Cal. Only we have 2 different IB Pre-Cal classes, one called HL, mathematically we give it the course code 30 after the end, and SL, mathematically again we like numbers, we put 00 on the end. Both of these courses are Pre-Cal, and it's just that the Pre-Cal HL course prepares kids for BC Calculus and the SL does for AB Calculus. That means that there's extra topics that kids in BC Calculus have to have, and so the precursor to those topics are in the HL Pre-Cal and not in the SL. It doesn't mean that everybody in the Pre-Cal HL definitely goes to BC Calculus. Some kids after Pre-Cal HL choose to go to AB. So I know that's a little confusing there, but what this means is that one of these courses is next year, and then one of these courses is the year after that. Optional is that you can take AP Statistics. Any student that has finished an Honors Algebra 2 class, of which of course AAF qualifies, can take AP Statistics concurrently. You don't get the choice to take it as a standalone course until after you finish calculus. But you can take it concurrently, and there are about, as you can see, 33 to 35 students each year. There are 33 this year, and they take AP Stat along with AP IB Pre-Cal HL. If you're taking IB Pre-Cal SL, those students do not take AP Stat concurrently. They could, it's just that too much math seemed to be a little bit overwhelming. Now these 33 students always do well. They are primarily sophomores in AP Calc, as well as taking IB Pre-Cal. Every once in a while a counselor will call me and say, oh, student blah is feeling so stressed because they're in IB Pre-Cal and they have a test, and they're also in AP Statistics and they have a test on the same day because they're both math classes. That's how it goes. If you are signing up for 2 math classes, that is optional. And if you have chosen to do that, you may not whine about the fact that you have double the math homework. Math classes follow the same format, right? You pretty much have homework every night, and then you have quizzes in the units, and then you finish a unit with a test. So, as again, you can see by this statistics here, students do well. Right? You will do well, in these courses, but you can't complain when you've chosen to take 2 math classes in the same year. So, recommendations for which pre-cal that you're going to take. We base those recommendations on your semester average, because we know, we've been following this data for many years, and if in my class or in AAF, if you earned as a semester average lower than 85%, you will be most comfortable in the IB Pre-Cal SL, right, or the one with the course code 00 after it. Students who were, had to work very hard to get that B, or maybe earned a C or whatever in AAF, you're going to be much more comfortable in SL, and you'll be able to earn that A and B for your transcript. That will be your recommendation. If you choose to go wave above our recommendation, it's not a mandate that you go to IB Pre-Cal SL. You have the prerequisite course. You have passed AAF. You have the prerequisite course to go into HL, the IB Pre-Cal HL. It's just that it is a very challenging math course, and if AAF challenged you, IB Pre-Cal HL will challenge you even further. So again, our data shows that if I recommended you for SL and you chose to take HL instead, those students, most of those students, get C's and D's on their transcript. However, students who did well in AAF, they got greater than or equal to an 85% as a semester average. Most of those students are certainly challenged in IB Pre-Cal HL, but most of them get A's and B's on their transcript. So lesson learned, your recommendation is based on your performance and with data as a background. So we're not doing it because, we're just don't like you or, whatever. But to take the best care of your transcript, please follow the recommendation. Remember, you can sign up for whatever right now, right? Sign up for what you're recommended for right now. And then it is only, the end of January and February, for goodness sake. If things change through second semester, all of a sudden, the math becomes very easy, you've got the hang of high school, you're just convinced that, your performance and you're ready to take on the challenge of HL even though you were recommended for SL, go for it. But nothing that you do right now is written in stone. So just sign up for the recommended for and then go from there. Here is just the basic chart, FYI, for what classes students can go to. So this first band is 9th graders, so if you're a 9th grader right now in my class, this would be you. If you're a 10th grader in my class, this would be you. So as you can see, from AAF, you can go to either IB Pre-Cal, the HL, or the SL. Same if you're a 10th grader, HL or SL. You do have a choice here if you're a 10th or an 11th grader. Currently in my class, you can, and AF has really been a struggle for you, you can go to IB Math Studies, which does a little bit of pre-cal and a teeny tiny bit of calculus, even very just graphical analysis of calculus, and allows you to test take an IB test and be done with IB Math at this point. So that is a very nice course for students who, their other courses are going just fine, but math has just always been a serious struggle. The only thing is you can't get into this class unless you are at least a rising 11th grader. So if you're a 9th grader here in AAF, you don't have that choice. 9th grader, you have to go into one of these IB Pre-Cal classes. But notice from IB Pre-Cal HL, most students do go to BC Calculus from there, but some students choose to go to AB. which is also for magnet kids called IB Math SL, because you'll be ready to take your IB test then after that class. You could also take it after BC Calculus, but most BC Calculus kids keep going to IB HL course, not pre-cal HL, IB HL. Right, there's a difference between IB pre-cal HL. That's just HL just means you're getting the topics that would prepare you for BC Calculus and then for IB HL. If you go the SL route, you are not getting the topics here that would prepare you to go on to IB HL. You would be done with IB Math at this point, but you could still, I have many students, about a third of the BC Calculus kids currently came from AB Calc. And again, if you go to IB Pre-Cal SL as a sophomore or as a junior, your choices from there is to go to AB Calculus, which again for magnet purposes we call IB Math SL, or again you can go to the Math Studies, that's this course, the same as this course here. And then there's lots of choices after that, which you can go, we've actually added some 2 electives after calculus, logic and linear algebra. But you don't have to worry about those until you are done with either AB or BC Calculus. Any questions, you can certainly ask and talk to me. I will give you your recommendation as well as your semester average so you can know why you got the recommendation you did. And remember, a recommendation is just that. If you are recommended for IB Pre-Cal HL and you want to take IB Pre-Cal SL, we have kids that do that. If you're recommended for IB SL and you really want to take on the challenge of IB Pre-Cal HL, we have kids that do that too. Don't have to make a decision right now. Wait until this second semester of AAF before you really make a decision. All right, enough of that. Oh no, I did want to tell you that for University of Maryland credit, right, credit for math classes. IB math exams are really good, you need to get through them for your IB diploma, and which is a really good transcript builder. And you get scores on your IB math exams towards your diploma. But no standard level math exam, be it IB Math Studies or IB standard level, gets you any college calculus credit. If you take IB higher level, they figure, it's not really a calculus class, but there's enough higher level math in that they figure you know Calc 1 as long as you get an IB score 5 or greater. And remember, IB exams are scored on a 1 through 7 scale. For your IB diploma, you think about that you need to average a 4 on all of them. So you consider 4, kind of like passing. Calculus exams are written to get college credit. So now credit varies by college. You can find small liberal art colleges that give lots of credit for an IB math exam. I've just given you what University of Maryland does, and you can certainly look up any college that you're interested in and find out what they would give for different exams. But University of Maryland system for the AP Calculus exam, they consider that AB is like 1 semester of calculus as long as you scored a 4 or above. And BC, they consider 2 semesters of calculus, college, Calc 1 and 2, as long as you have a score of 4 or above. And remember, calculus exams, AP exams, are on a scale of 1 to 5. 3 is considered passing, but for college credit, and oftentimes you need a 4 or higher. Again, some colleges take a 3, it just depends. Other colleges, a serious engineering college, even for a BC, a score of a 5 on a BC may or may not get you calculus credit, simply because they want you to experience the calculus course from a college professor. And truly, my advice to all my students, if you're going into engineering, I would certainly take at least 1 semester of calculus, again, at my college, no matter what score that I got. Learning calculus in college is vastly different than in high school. Even though it's really hard in high school still, it's not the same. Just my advice. All right, so now for real, we're going to start. Don't forget you need warm-up books. The homework that is going to go with this lesson is a half sheet of factoring practice that will be on Edline for you to download. So, Unit 6, Rational Functions. A lot of previous knowledge I'm going to assume here. Your factoring knowledge, I've been warning you since August that if you feel like you are lacking in factoring, go to Khan Academy, go to, bookstores, websites, whatever. It doesn't take a lot to practice factoring. You can find a lot of practice problems anywhere. It's like going out and shooting free throws. You just got to do it. The factoring, remember, is not solving. You are just being asked to break down expressions into different forms, like breaking down 12 into 4 times 3, or 6 times 2, or 2 times 2 times 3. Greatest common factor is your first shot. Always pull out a greatest common factor if you see it, be it a number or be it variables. For quadratics, seeing a pattern of difference of 2 perfect squares, recognizing a quadratic trinomial that is a perfect square, these things will speed up your factoring if you see those patterns. And then just if you have a quadratic trinomial, its leading coefficient not equal to 1, most of you are very good as long as the leading coefficient is 1, but if it's not, you get a little stuck. You just need to increase your speed with that. What does that take? Practice! And then of course I can give you some problems that are combos of all of the above. So I'm just going to dive right into it. What do we see here? 144x squared minus y squared. What do I see? I'll take you through my thinking process. I see 2 terms. 1, 2, a minus sign, and these numbers ring bells in my head. 144 is a perfect square. 49 is a perfect square. A difference. Is this a difference of 2 perfect squares? Whoop, sure enough, x squared is a perfect squared and so is y squared. So what do I do with that? I know that the difference of 2 perfect squares factors into 2 binomials, one a positive factor, one a negative factor, and I put what makes 144x squared perfect is 12x, what makes 49y squared perfect is 7y, and I repeat that over here. You can always check to see if you're right by distributing. Sorry, keep hitting the button on my pen there. Checking to see if it is correct. And of course, you get 144x squared minus this product plus the same product will cancel out. Check. Look at this one. Notice that I kept the first and the last term from the other problem, except I changed the sign of the 49y squared to positive. So this looks devastating, such a bunch of high coefficients, but again, 144 and 49 make me think to check a pattern. This is a trinomial, right? 1, 2, 3 terms, and the first and third are perfect squares. So I wonder to myself, and I say self, could this be a perfect square trinomial? I don't know for sure, but the 144 and the 49 mean I'm going to check. So I say, yep, perfect. Yep, perfect. Now I wonder if the middle term is a result of a multiplied double issue. And here's what I mean by that. What makes 144x squared perfect? 12x. What makes 49y squared perfect? 7y. What happens if you multiply 12x and 7y? When you multiply them, double that. Do you get 168? Yes, you do. Therefore, I know that the 12x goes there, the 7x goes there, and the sign of the middle term comes in the middle. How do I know if I'm right? How do I know if I've recognized the correct pattern? And again, this is just recognizing a pattern. I saw 3 terms with the bookends here, book, ends, perfect squares, so I checked. I did not know, I checked to see if this fit my perfect square trinomial pattern. And now I will expand this. Squaring something means writing it down twice and multiplying. What happens when I multiply here and here, here and here? I certainly get this back. Next, two problems. Both of these are trinomials, right? 1, 2, 3, and this is the second problem. 1, 2, 3. I do not bother checking my perfect square trinomial because neither of the bookends are perfect squares, but I do know that this is a quadratic. Every quadratic has two linear factors. So I say to myself, how can I factor 3x squared? There's only one way I know of, 3x and x. So if that's true, the 3x and 3x, how do I factor 45? And what factors of 45 can I put here and here such that when I distribute and combine, I get 6x in the middle? There are people that have lots of different ways to manipulate this. Boxes, ladders, splitting middle term, blah, 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 blah. I don't care how it's done. Every single process is just an organized way of guessing and checking. The better, more, terrible English, the more you do, the better you get. Just like shooting foul shots, just like practicing scales on a piano, just like any algorithm, the more you practice, the better you get. So when I think of factors of 45, I don't put 45 in one here. That's a legitimate shot, but I've done this enough that that's not my first guess. My first guess was 15 and 3. Whoops. Does putting a 15 and 3 here, 15 and 3 are certainly factors of 45. What happens when I multiply 3? What happens when I multiply 3x times 3? I get a 9. And if that 9 was negative, combined with a positive 15 times an x, that certainly will give me 3x squared minus 9x plus 15x minus 45, and the middle terms combine. And I'm happy. And again, my guess, I could have tried 45 and 1, I could have tried 9 and 5, I could have tried the reverse of all, there's lots of things I could have done. I guessed 15 and 3 because in my head I have factored 45 plenty of times, and I've done this kind of manipulation with quadratics enough that that happened for me quickly. It will for you too if you dedicate enough time to just practicing. So how about over here? This is annoying because 6x squared isn't prime like the 3x, so I have to try 3x and x. That might work. Whoops, sorry, no it wouldn't. 3x and 2x. That might work. Or I might have 6x and x. I'm not sure. I'm going to break up 14. What things of 14 might work? Might it be 7 and 2? What happens when you multiply 3x and 7? You get 21x. How about 2 and 2x? You get 4x. Can you combine 21 and 4 and get 17? Again, I might have started with 6 and a 1. I might have started with 14 and 1. I might have done a lot of things, but I know that since I want the 21 to be positive and the 4 to be negative, this is the combination that is going to give me 6x squared plus 21x minus 4x minus 14, and that combines to my 17x, and I'm happy. Next, sorry. These are regular, to recap, regular quadratic trinomials where your leading coefficient is not 1. Because they're quadratics, I knew that I was looking for a product of two binomials, and I just had to factor the 3x squared there, find which factors of 45 went there. And if nothing else, you guess and check until it works out. So check out the next example. Notice what's different. You still have 3x, 6x, and 45. It's not a regular quadratic trinomial, is it? It's a 4th degree. And I think, no! Factoring higher than quadratics means I've got to do long division. Boo! Cry, cry, cry. Or, which is true, that's not a bad thought, but maybe, and what led me to this kind of thinking is the fact that it is a 4th degree, but notice there's no cubic term. It's a 4th degree with 1, 2, 3 terms. So no, it is certainly not a quadratic, but it looks an awful lot like the quadratic I just factored, right? Remember when it was 3x squared plus 6x minus 45? 3x squared, 6x to the first, exponent rules. An x to the first and an x to the first, right? When you factor 3x squared, you're going to get an x to the first and an x to the first. And when you add an x to the first and x to the first, you're going to get another x to the first. Well, check this out. This is an x to the 4th. When you factor an x to the 4th, one of the ways you can factor it is as an x squared and x squared. And if you add two x squared things, you will still get an x squared thing, right? If I confused you yet? All right, watch. Yes, that's a 4th degree, and that is a 2nd degree. I wonder if I can use this thinking. Remember this thinking before when I had 3x squared? I said, I'll put 3x here and x here. And then I looked at the factors of 45 and I ran through a couple of, choices, and I settled on the one that gave me 6x in the middle was the 15 and the 3. Right? Remember, because 3x times x is 3x squared, and I wanted the 9, 3x times negative 3 to give me a negative 9, and a positive 15x times x. Combining those gave me a positive 6x. Well, factoring 3x squared gives me 3x and x, but can you think of how to factor 3x to the 4th? Wouldn't that be 3x squared and x what? Squared. True? And now what happens? Right? Look what happens. What happens now if I go ahead and check this out? Okay, so let's foil this, right? Even though I can't stand that acronym. Let's do 3x times x squared and 3x squared times negative 3. What does that give us? That gives us 3x to the 4th minus 9x squared. Next, let's do positive 15 times x squared and positive 15 times negative 3. What does that give you? Positive 15x squared minus 45. Hey, look at those middle terms. Doesn't that give me 3x to the 4th plus 6x squared minus 45. So if you multiply two things together, I took this factor, or this binomial, and multiplied it times this binomial. I followed the rules of multiplication, and I combined like terms, and I got this result. And that result matches this result. What must be true? It must be true that these are the two factors of 3x to the fourth plus 6x squared minus 45. Now, I am going to look at both of these factors since each of those is quadratic, and I wonder if they can factor further. And my answer is no. So to recap, what if I told you that I wanted you to factor 12? And you said the factors of 12 were 6 and 3. True? No, Dippy. 6 times 3 is not 12. These are 6 and 3 are not factors of 12. Why aren't they factors? Because when you multiply them, you do not get 12. However, is it true that 6 and 2, when multiplied together, generate 12? Yes, therefore, 6 and 2 are factors of 12. And of course, you can break 6 down even further. So, these two binomials, when you multiply them together, you get this fourth degree. Therefore, it must be true that these two binomials are factors of the fourth degree, for the same reason that you agree with 6 and 2 being factors of 12. Cool, huh? Pattern recognition. Huge in upper level math. All right, look at this one. The first thing that jumps out at me in this is there's a freaking common factor. And that factor is a number, and that number is 2. So I don't have to do pulling out the greatest common factor, but it sure helps. It often helps bring down values of coefficients so I can deal with the second factor more easily. So technically, I have already completed one factoring step. Pulling out a greatest common factor means you have factored. And I pulled out a 2. 2 is common to everybody. Then I will look at the remaining factors. Now, even if 2 had been, let's say, 12, when we're dealing with polynomials, it is not expected that you break down a dilation factor. So you can leave that 2. You don't have to write it as 2 times 1 or anything. But you need to look at the second factor, because that's a quadratic trinomial, and determine if that quadratic can factor further. And I'm going to tell you that it can't. It's prime. Now, this kind of flies in the face of what we learned in our previous unit. X squared minus 4x minus 4 is a polynomial. It is a second degree polynomial. It has 2 factors. It has 2 factors. And remember the relationship between factors and x-intercepts. The graph of this quadratic right here, you ought to know from previous units. Right? The graph of that is a parabola that opens up and has a y-intercept of -4. It freaking has 2 x-intercepts. So why is it called prime? Because I know I can take x-intercepts and turn them into linear factors. Here's the graph of x squared minus 4x minus 4. Again, y-intercept here. So here are the 2 x-intercepts. Right? But do you remember this, what I'm about to do? Right? B squared minus 4ac is 16 plus 16, which is 32. And because 32 is positive, the parabola has 2 x-intercepts. But since 32 is not a perfect square, those 2 x-intercepts are irrational. So that's a hint to what prime polynomial means. And let me refresh your memory about prime numbers. Isn't it true that 13 is equal to 7.5? No, 6.5 times 2. There are two numbers multiplied together to equal 13, and yet we say 13 is prime. The reason that is because there is a definition of prime numbers in that a number is called prime if there are no integers besides itself and 1 that multiply together to generate that number. And 6.5 times 2 does equal 13, but 6.5 is not an integer. So something similar is true for polynomials. The definition of a prime polynomial. You should have this in your notes. A polynomial is considered to be prime. Remember, this is if and only if, which means it's a biconditional statement or a definition. A polynomial is considered to be prime if and only if its linear factors cannot be written in the form x, no coefficient on x, besides 1, minus c, where c is an element of, the set of rational numbers. So I'm going to go back to this slide. This quadratic does factor. It's just that it factors into linear factors where the c, the x minus c, would be an irrational number. Therefore, when I ask you to factor this quadratic in this unit, you will write prime. As I showed you, the discriminant can sometimes help you whether you bother to try to factor something. If I'm just giving you a list of quadratics and asking you to factor them, some of them might have low enough coefficients that you can just automatically see, yes, I can factor this, no, I can't. But sometimes you need to look at the discriminant and then say, you know what, I'm not even going to bother to try to factor this because the discriminant is either negative or not a perfect square. And remember, 0 is a perfect square. So if the discriminant is a perfect square, then your quadratic is not prime, and you can go ahead and try to factor it. If the discriminant is not a perfect square, well then it is prime, and no, just write down prime and move on. So for example, 3x squared minus 2x minus 4. If I'd asked you to factor that, right, you could try, you could sit there and you could make your, and try and find combinations, and it wouldn't take you so long with coefficients that are this small. But I went ahead and calculated a discriminant, and I got 4 plus, 12 times 4, which is 48, right? Or 16 times 3, either way you look at it, and a negative times a negative is a positive. 48 plus 4 is not a perfect square. Therefore, while that quadratic does factor technically, when in this unit, when I ask you to factor that particular quadratic, you write prime. Also, sometimes the characteristics, if you know something about graphs, which is again why we study polynomials and their characteristics. If you have specially quadratics, you know very well, any quadratic of the form x squared plus a number, and I do mean plus, in other words, where it's x squared plus 25, not plus negative 25, would be prime. So for example, x squared plus 12. You ought to know that that is a parabola that opens up and its y-intercept is at 12. There are no x-intercepts. So there are two solutions and two factors, but they're not real. And in this unit, when I ask you to factor, the only factors that you're required to give me are those of the form x minus c, where that c is a rational number. So x squared plus 49, prime. X squared plus 25, prime. And I can't tell you how many times I get kids that say, oh, no, I can factor that. Look, it's x minus 5 times x plus 5. No, it's not. This is x squared minus 25, which is not equal to x squared plus 25. Oh, that's right, Miss Katz, I'm sorry, it's x plus 5 times x plus 5. Is it really now? No, it's not. That's x squared plus 10x plus 25, which is not equal to x squared plus 25. you find me two factors of the form x minus c, where this number is rational, to combine to get x squared plus 25, and we're going to have to make some calls. We're going to have to rewrite some textbooks. Now, on the other hand, x squared minus 25 is not prime, right? Prime, prime, prime. X squared minus 25, not prime. You should recognize that as the difference of two perfect squares. X squared minus 12 is not, x squared minus 12 is still prime, isn't it? Right? I tried to trick you there. This one is still prime. Why? Not because it doesn't have any x-intercepts. X squared minus 12 does have x-intercepts. Matter of fact, they're at plus or minus root 12. However, in this unit, we're going to call that prime because I can certainly write this as x minus root 12 and x plus root 12. And you just think you're so very, very smart, but you're not going to get credit for that. I've given you the definition of a prime polynomial now, and you are responsible for it. How about x squared minus 49? Not prime, right? Because 49 is a perfect square. And therefore, you can factor it where you could write it in the form x minus a number, and that number is rational. So, for your homework tonight, you need to go to Edline, and you need to look under our math groups page. And look for handouts. Unit 6. And there is a sheet of, I think, 10 maybe factoring problems that you need to complete for homework. So consider this today's lesson and today's homework. So that would be, what is today, Wednesday? Wednesday, so this is for Wednesday. And then we already have off school tomorrow, Thursday, so there will be another video with more homework coming Thursday. Aren't you excited? Cool. All right. I will see you not tomorrow, but I will see you tomorrow. Right? Have a good one. Bye.